Hi guys, and welcome to the Euclidean Geometry series. Okay, with Mr. G here, of course. Now, Euclidean Geometry is one of the interesting topics in a sense that it is very easy, but students really find a hard time understanding this, and it's a nightmare to them. So I have tried to think around the way I can introduce this to you. And I thought actually we should start by having some fun. What do I mean? If you think of Euclidean geometry, guys, it is not really different from the geometry that you have studied. You have studied lines, for example. Here is a line, AB, okay? Here is a segment. A segment has a definite starting and ending point. And what else is there? I can actually also determine the length of this segment, isn't it? So I can actually determine the length of the segment here. I can see it's 5 units, and you've studied all different types really of lines. Okay, so what we do in Euclidean geometry, okay, actually another name for Euclidean geometry is circle geometry. So what we do in Euclid geometry is we're going to look at the behavior of these lines, but in a circle, in relation to the circle. Okay, that's what we're gonna do. So what's gonna happen, you will see that now we're gonna come up with theorems. Theorems are statements that have actually been proven, are facts, mathematical facts, if you may say. So what we're gonna do now in the next coming sections is to study the behavior of circles and lines. When lines are formed inside a circle, what is the behavior? When lines are formed outside the circle and they touch the circle, what is the behavior? After doing that, we're now going to study quadrilaterals inside a circle, quadrilaterals touching a circle, and then of course you extend this in grade 12, you go on to study triangles in depth. In fact, we're also gonna study about triangles in a circle. Okay, so without any further ado, let me just do this here and maybe remove my no, that's a big circle. I actually want to remove the grid background, so that I'm left with a plain background. And I'm gonna kick off this discussion by talking about the circle. Okay, so let's draw a random circle through 3 points. There's point A, there's point B, and here is point C. Don't worry about the radius. And maybe one thing that I should do here is I should have mentioned actually the center of this circle. Okay, we might need that because of the theorems that we are going to discuss. So what I'm gonna do right now is to actually construct a circle with a given radius. So let's see, there we are. There's the radius of our circle. Because we have a center, I can move this circle wherever I want. So what I'm gonna do here is I'm gonna plot another point. Okay, there's a point. I'm gonna plot another point here. I'm gonna plot another point. I've got 3 points. Okay, hope you can see those. That is point A, B, C. Okay, here's point C, there's point A, here is D, and the okay, A is in the origin. Okay, is the center, right? Now, one thing that I'm going to show you here is the behavior of lines around the circle. The first line that I'm going to draw a line, and I will also be introducing some definitions for you. I'm going to draw a line BC or CB, whichever way you may want to call it. When a line is in this form, guys, we call it a chord. Okay, maybe I need to write that down. This line here, okay, we call this line a chord. So for now, I'm just going to actually work on definitions for this entire video. This line there is a chord, but here's an interesting thing. With a chord comes another nice line that has a name. So I'm going to use a different color here. This line here is a line. You can see actually it's meant to come down here. It's meant to be skew like that. And of course, I'm using freehand. It is quite difficult to come with that. Nonetheless, guys, what you need to understand here is that this thing here in purple that I drew is also having a name, okay? And we call it an arc. That's what we call it. You can just see it forms a small portion of the circumference, all right? And obviously, if I were to draw a line, I'm sure you know this one. If I were to draw another line from the center, for example, here, then we call that one what? Radius, right? And if I were to draw another line from one end of the center to another, actually passing through the chord, passing through the center. Look at this. I'm going to draw a line passing through the center, coming to point G. That line, we call it the diameter. So I hope you can see that as well. That's another important concept for you guys. Actually, it will not be a good idea for now. Okay, when we do theorems, it will be a good idea, but I'm actually going to delete this line here and then draw a better chord here so that I do not confuse you. So this thing here is a chord, okay? And then I think that will be proper. And of course, another thing maybe that I should talk about is the concept of what we may want to call a secant. Not really important, but for interest's sake. Now, if I draw a line instead of a segment like this, then this line, check this, that line there is called a secant. Of course, this one is not really important for now. As I said, it's just a matter of exploration. Okay, maybe it might be good for you to be familiar with that. So I'm going to take it out because I really don't need it for this in discussion. Now, this point here, this chord, okay, so let's have the names. I'm going to write down the names now. Okay, we know that so far now we know FG is a diameter. We know that AD as well as AF, actually they are equal, and AG, these are radii. Okay, they're both lines from the center to the circumference, okay? And we know that EB is a chord, okay? As a matter of fact, a diameter is a special chord that passes through the center, okay? Well, so we can just say this is a special chord, just that it passes through the center. That's another thing. And finally, the last line maybe that I must talk about is the tangent, okay? And then we are done with definitions. I'm gonna talk about the tangent. So if I've got a line that's gonna pass through a point, this is very important, through a point on the circumference of the circle, we call that line a tangent. We call that line a tangent. The final thing that I'm going to talk about is the concept of a segment. This thing here is called a segment. And this entire thing here also is a segment. In other words, a chord divides a circle into segments. Okay, so this one is a major segment, that's a minor segment, and of course a segment, and of course a chord which is a diameter will divide the circle into two equal segments. That is another important concept. I will leave it here, guys. In the next video, we are now going to kickstart our discussion on the study of lines that are within the circle. We have studied now, we have just had a look at definitions of lines in relation to the circle in general. Lines can be inside a circle, they can be outside the circle, and they can pass across the circle like the second as you saw. Now, in the next study, the next video rather, we are now going to have an interesting study on the behavior of such lines as they pass through the circle. Stay tuned.